Okay, welcome back to the next part of this Earth to Mars video that I'm putting together. So let's go ahead and unpause the simulation and pick up where we left off. In the last part, we simply we had brought the vessel, the XR2, up to orbit, and we circularized the orbit. We got our vessel into the best plane that we could get, with our plane alignment, and then we completed the ejection burn to head out to Mars. But we're still right here at home. Take a look at the external camera just to see, we haven't gone anywhere yet. So the next thing to do is wait for a year. So this is going to be a long video. We're going to sit here for a year and wait for the XR2 to get to Mars. So I hope you got plenty of time on your hands. Of course, I'm kidding. I'm going to go ahead and use a little bit of time acceleration. A whole lot of time acceleration to get out to Mars. And bring up an external MFD. And I guess probably this TransX one's the best one to look at. And we'll go to the external view.
Rotation.
Make sure I have rotation selected so I can kill rotation as needed. And we're going to go ahead and accelerate away from the Earth now. Okay, kill rotation. I want to make sure I've got global frame. I find that usually works best. Okay, here we go. I believe I read in the TransX documentation that the best time to do the first mid-course correction for any type of interplanetary flight is when Earth's gravity will have no noticeable impact on the TransX MFD. Now, technically, you're probably better off doing a mid-course correction before that point if you had an MFD that had a better math model. But the math model that TransX uses can be confused, for lack of a better term, when it has to deal with lots of gravitational sources. So we want to get all the way away from the Earth so that the Earth's gravitational readout according to MFD is basically, like 0.01 or something very, very low. So let's kill rotation.
Translation. Rotation.
And let's warp out at 1,000. And it should be fairly obvious that what we're looking at here in TransX is our plan for, leaving the Earth. Got the moon over there. And we can do some 10,000. And let me go back to real time for a moment just to see where we're at. See, the Earth's gravity is still showing 0.22. So if I understood the documentation correctly, you could definitely do a mid-course correction already, but I think TransX works better if you get a little further out. So we'll continue on at 10,000 for a while. A little bit of kill rotation to keep the vessel from spinning around. And we'll go back to real time. And we've got the gravitational readout showing that we're all the way down to 0.05. We'll go a little further yet. Go back to 10,000. There's the Earth and Moon. And we're probably at a good time to think about a mid-course correction now. In fact, probably when that plan changes from the escape plan over to the eject plan. That's my guess as to when the when the preferred time is for that first mid-course correction. Probably right about then. And we could go out even a little further than this, but let's go ahead and do our first mid-course correction at this point. So we'll do what we usually do. Bring up TransX on both sides. And over here we will press VW to bring up the maneuver. I'm going to put that on orbit just so it doesn't confuse me. And we'll turn maneuver mode on. And hopefully we can get a good mid-course correction with the minimal amount of fuel usage. So I need to go through the variables. And over here on this side, I'm going to come over to View, Encounter. And now I'm just going to start working with these variables until I come up with what I think is the best solution, while hopefully using the least amount of fuel. So let's start with, I'm going to say we'll start with outward. Generally when I make this type of mid-course correction, that's often the one that works better. So going positive is increasing my closest approach, and that's not what I want. So let me go backwards, get that back to 0, and then we'll try going the other direction. And I can see, this is bringing the closest approach down, but this is an awful lot of delta V. So let's just reset this. And instead of using outward, let's start with prograde. Okay. Going forward's not helping. Let's go backwards. And you can see we're using significantly less delta V, and we're getting a lot more improvement. Still quite a bit of delta V to be using, but and there we've reached the point now where we're close enough with the rough approach that we're getting information down here on the view encounter. So we'll just keep going with it. I saw it passed over and went the other direction. So now we'll add some prograde back in. And we're basically just doing the exact same thing that we did when we were still on the ground. We're just dialing in the best setting here. Looks like something about right there. And now, undoubtedly, the next best variable is going to be the change plane variable. And again, I don't know if positive or minus is going to benefit me, so we'll start positive, and looks like that's the right direction. Okay, now we'll go to an adjustment. Okay, so this has us coming out to Mars, and it says our minimum altitude will be 285 kilometers. And at this point, we're still really far away from Mars, so I'm definitely not going to worry about trying to pick an altitude that would be, what I want to have when I get there. So we'll just go ahead and burn this maneuver just like this. So VW to bring up view target.
Translation, rotation.
Bring up rotation. And we've got 82.87 worth of delta V that we need to use here. Oops, pressed the wrong button there. Okay, probably right about there. Maybe a little more. That's good enough. Okay, now we'll add a little bit of main engine. And we're just going to bring that delta V all the way down to 0. Okay.
Translation.
Now we'll translate the rest of it. And that's always good enough for me, 0.00, and I don't care what the rest of the decimal points say. Okay, view over to maneuver, and we'll turn maneuver mode off. Go ahead and close this out. And of course, there's a lot of volatility here with regards to our actual encounter at Mars, so things are still going to change. That's to be expected because we got a ways to go yet. But at least that gets us a little more on target. Okay, so we're just going to warp time ahead. Take a look at the external view while we do that. And we'll go all the way to 100,000x. And I'll probably start thinking about my next mid-course correction somewhere over this way. I think somebody commented in one of my videos wanting me to do an Earth to Neptune or Jupiter something, Saturn, I don't remember exactly what it was, but one of these days I'll probably get around to doing that. One problem I'm going to have with a video like that is these interplanetary flights, even with 100,000 times time acceleration, just takes a really long time to get from one point to another. I remember one time I did the whole grand tour. You know, I set up TransX and I did the Jupiter, Saturn, Uranus, Neptune, you know, the grand tour like Voyager did. And I think that took me like 8 or 9 hours. And a lot of it was spent just sitting there at 100,000 times time acceleration, going from one planet to the next. Even at that enormous time acceleration, it still takes like 25 minutes to go from, I think it was from Jupiter to Saturn, and then from Saturn, you know, to Uranus. Just, I mean, imagine that, sitting there for 25 minutes at 100,000 acceleration. So it wouldn't make for the most exciting video. So I would probably have to do all kinds of pauses and edits, and I really don't like to do that. So that's why I find these types of videos a little easier. So we're getting to another point here where a mid-course correction would be a good idea. So let's jump back inside. And see, we've been gone for 135 days. And we have 285 days of oxygen left. So we're still in good shape. Let's go ahead and make this nice and large. And we've already got view encounter over here, so we're good. Turn maneuver mode on. And, you know, rinse, repeat. Go through the variables. And I'm pretty sure at this point, outward is going to be the best bet. And we'll see. So we'll start with some medium outward. And we'll look at this closest approach. Okay, adding positive. Okay, that brings it way down, but again, that's a whole heck of a lot of delta V, so maybe that's not the best choice after all. So I'm going to reset that variable, and we'll look at prograde again. And we're a little better with prograde. That's still quite a bit of delta V, but it's about half as much as I was seeing before. Okay, and I'm assuming by now you understand what I'm doing and I don't have to explain, you know, plus, minus, back and forth. So, okay. Okay, we'll go with that. So press VW, bring up the target.
Rotation.
One thing I don't like about TransX is when this X is in this position, I do not know if I would be better to yaw to the left or to the right. You know, I have no way of knowing. So I'm just going to choose to go to the right, and I got lucky. That was the better way to go. Okay, we'll go with that. And now we'll engage the main engines to burn through that delta V that we need to get.
Translation. Rotation. Translation.
Okay, we're almost at 0. Okay.
Rotation. Translation.
And there we have it. Over to maneuver view, and maneuver mode off. Okay, we'll go ahead and make this a little smaller. So what I'll do now is I'll go ahead and continue to close the distance between my current location and Mars, and then once I get out to that point, I'll go ahead and end the video for this part, and we'll pick up everything that we need to do at Mars in another part. So let's go ahead and warp time ahead to close the rest of the distance out to Mars, and we may still have another mid-course correction to do. We'll see where we're at when we get out to about this point. So here we go. Warping time ahead. 100,000. You can see down here our minimum altitude is increasing. What I find often happens is you'll get to this point, maybe even right here, and then the minimum altitude will start regressing. It'll start going back the other direction. So I wouldn't necessarily jump the gun on doing another mid-course correction at this point, because let's just see what happens. So we're saying our closest approach right now is about 4,000 kilometers, and I'm willing to bet that once we cross this point, it will actually start going back the other way. That's generally what I find happens. Matter of fact, you can see right there it's already starting to top out. Now it's going backwards. So that's why I typically try not to jump the gun on doing mid-course corrections too quickly, because as you move through space, the different variables change, and sometimes things start to work better in your favor like they are now. We're getting closer instead of further away. So we are at 5614, let's call it 56150, and we got to get to 56256. We've still got over 100 days to go. Keep in mind this is the point where we're supposed to catch up to Mars. We've crossed over the orbit of Mars at this point, so we're actually further away from the Sun than Mars is right now. And our minimum altitude is continuing to get closer to the planet instead of further away. And I consider that a good thing. Looks like we may be bottoming out here shortly, and then the minimum altitude will start going back up. But at least it worked in our favor there for a while. Okay, let's check our dates. Let me slow things down here for a moment. Okay, we're going to encounter Mars on 56256, and we're at 56235, so that's about 20 days. Yeah, it's about 20 days. So let's press forward a little further. I don't feel the need to do a mid-course correction when we're still this close. Let's get out to 56240. Okay, and yeah, let's go ahead and do a little bit of a mid-course correction. Be a very small one here. Maneuver mode on, and let's try outward. Okay, adjustment. Just a little bit of negative outward, it looks like. Yeah, we'll just need basically a whisper of thrust. And I'm going to work on trying to do an atmospheric braking. That way we don't use any more fuel than is necessary. So we're going to go for a target altitude of, we're going to get in there pretty low. Okay. Now I need to do just a little bit of a plane change. Okay. Oops. Let's go with that. Let's go ahead and burn this maneuver. It's only 5 delta V.
Rotation.
Okay. Okay, we'll go with that. And just a little bit of main engine because it's a very small amount of delta V, so just one little click there.
Translation.
Okay. Okay, we are almost to Mars. We've just got about, what is that, 2 weeks to go? 56240, 56256, that's 16 days. Okay, let's warp ahead and get closer. Any final adjustments that we need to make, we'll probably make those just within the last few hours, like when we can see Mars. So let me keep a really close eye on this date now. "10 days, 9 days, 8 days, 5 days. Let me double check. Okay, 5 days to go. "4 days, 3 days. 2 days. Alright, let's see where we're at. Let me reference Mars and copy this information to the HUD.
Rotation.
And now let's rotate around. See if we can bring up Mars on the forward view. And there it is in front of us. Turn this off so you can see it. There we are. And let's get in just a little bit closer, and then I'll go ahead and end this video, and we'll pick up the rest of this in the next video. If you look really close there, you can see Phobos and Deimos. Okay. Alright, I'm going to say that is close enough, because if I need to do any final changes here, I want to be able to do them when I'm still a little ways out. So I'm going to go ahead and end the video at this point. Let me pause it, and we'll pick it up in the next part.